Okay, folks, we're ready to resume the Trailblazer Talks. And up next is Daniel Egan. He's the technology evangelist for Microsoft here down in LA. And his subject matter is you talking to me why NLP is making bots the new apps. Daniel?
Hello, everybody. How you doing today? So this is going to be difficult for me. I'm a roamer, and I got to stay behind the mic. So if I start dipping and you can't hear me, please let me know. So again, the talk is why NLP is making bots the new apps. My name is Daniel Egan, and I'm a technical evangelist at Microsoft. Yes. I can. How about if I hold it? That might help me. Hold on. Then I can roam, right? How's that? Is that better? Okay, good. So there's two things I got to get out of the way before we start. First, I'm not Dana White, and I'm also not Pitbull. So I get that a ton, so I got to clear the slate with that. I'm a technical evangelist for Microsoft, which means that I've been in software development for a long time, and I can also tell stories. And so what we do as technical evangelists is help developers be successful on our platform or other platforms as well. And so one of the things I like to do when I do a talk, when I talk about technology, I like to tell a story, and I like to share, and many of you may know this story, I like to share how we got to where we're at today. So this talk is mainly about bots, and this talk is about how NLP is going to change that, but how did we get to where we're at today? It all started with this guy. Does anybody know who this line drawing is? Yeah, somebody. Yeah, Lord Byron. So this is Lord Byron, and the reason he is important to this story is because, well, if you don't know Lord Byron, you might know his classic Don Juan, among other things that he's written. But why he's important to this story is because he had a daughter, and his daughter's name was Augusta Byron. So Augusta Byron was raised by her mother, and her mother didn't get along with her scoundrel father, Lord Byron. He left pretty shortly after Augusta was born. And so her cure to make sure her daughter did not go into the same lifestyle as her father was to give her mathematics and more mathematics and more mathematics. And so she grew up steeped in mathematics back in the 1800s. When she became adult, she married a gentleman by the name of William VIII Baron King. And in 1838, he became the Earl of Lovelace, which made her Augusta Ada King Knoll, Countess of Lovelace, or as you may know her, Ada Lovelace. So she's really interesting to this story because I already told you she was very deep in mathematics. And she had a friend, his name was Charles Babbage. He's known as the father of the computer. And he's known for kind of two things. One is the difference engine. And it's a mechanical calculator that was used to calculate numbers faster than any human could, right? But he kind of got bored of this because one of the reasons he got bored is it's designed to do one thing. So then he jumped over to what he called the analytical engine. The analytical engine was similar in structure in that it was mechanical, but it was designed to do multiple things. In essence, you could program it. And so that's why he's considered by many to be the father of the computer. Now, Ada, since she was his friend, he asked her if she would translate an article that a mathematician had written about the analytical engine, and she agreed. But when she decided to translate it, she wrote a bunch of notes as well, and more notes, and more notes. The notes were probably 5 times the size of the original article, and in there was 2 important things that came out of it. The first one is that she wrote an algorithm to calculate Bernoulli numbers with subroutines, and that's why she's credited with being the first programmer. But more important to this conference is she wrote this in the paper. The analytical engine has no pretensions whatever to originate anything. It can do whatever we know how to order it to perform. It can follow analysis, but it has no power of anticipating any analytical relations or truths. Essentially, computers cannot have artificial intelligence. And this irked many people, chief among them was Alan Turing, and he, again, is considered by many to be the father of artificial intelligence. And among the many things, fascinating guy, fascinating life. If you have not read up on him, just an amazing life. But what's important in this story of where we get to bots is Alan Turing devised a test, and the test is the Turing test, to be able to determine if a computer is intelligent. Then the test is rather simple. So you take person A and put him in a room. You take person X, B, whatever you want to call him, put him in another room, and then a machine in a third room. And if the first person cannot tell which one is the computer and which one is the person, it's said that it has intelligence. So that's the Turing test. So in 1964 at the MIT Artificial Intelligence Laboratory, someone up here was speaking earlier, and I guess his brother, a little bit after this, was at the MIT Artificial Intelligence Laboratory as well. But in 1964, the first chatbot was created, and her name was Eliza, after Eliza Doolittle from My Fair Lady or Pygmalion, if you remember the original. And it was meant to be a therapist. And if you think about how therapists talk to you, it made it easier to try and fool somebody, because they say stuff like, what does that mean to you? What do you think about that? So they could parrot back very easily. And so this was something that, from the Turing test, became the first ever chatbot. Now, the second chatbot is Perry, and he's a paranoid schizophrenic. And again, if you think about how a paranoid schizophrenic talks, they can kind of say anything, right? So I guess if you put a real schizophrenic in one room and this in the other, you might have a hard time deciphering which one is real, hence passing the Turing test. And of course, in 1972, if you have the first chatbot which is a therapist and the other one is a paranoid schizophrenic, they should probably talk, right? So in 1972, they did over ARPANET, and this is part of their conversation. But I do this, and I talk about the history whenever I talk about technology, because I like to see where we're at and how we actually got there, the lineage and the history to get there. But as you can tell from the text you saw on the screen, they're not very useful. And why? Why are they not very useful? And before we actually get into that, I want to talk about what a chatbot is. So many of you in this conference, I've talked to many of you, and people in the technology community understand what a chatbot is. But whenever I tell people that aren't in the technology community that I'm working with bots or working with chatbots, what do they think? They think I'm talking about robots. It's not a robot. So bot's one of those overblown terms. I'm specifically talking about, and what I talk to developers about, is conversation bots. So it's a computer program that simulates human conversation or chat, and usually today on messaging platforms, a Kik, Slack, Messenger, Skype, web, all those things. And so when we're talking about bots today, that's what we're talking about. So you can do things like, there's many things you can do, like book something through Expedia, or get tickets through Fandango, or get flowers, or it looks like pizza too. Looks like the makings of a great date night, right? But you can do these without human interaction. And these are probably more either you can call them brand bots, or enterprise bots, right? But what it does is it helps you in that first level of the defense. But to be able to get here, because we've had bots, like I said, since 1960s, right? To be able to get here, we had to fix a fundamental problem. And it's the same problem that we had with text-based adventure games. How many people ever played one of those text-based adventure games like Zork? Okay, so when you're in there, you say go east, go west, climb stairs, grab water. The problem with those games was if you didn't say it exactly correctly, it wouldn't know what you're talking about. You can see in this instance, he said what, and it says, what do you want to what? Or that's cool, and he says, I don't know the word that's, right? So it was incredibly tough. And the reason it's incredibly tough is because computers have a hard time understanding us. So NLP to the rescue. NLP, not NLP. So, and I purposely put this in here because if you search for NLP, if after this talk you're interested in this and you want to go play with it and you look for NLP, you're going to get neuro-linguistic programming. What we're talking about is natural language processing. So NLP is a way for computers to analyze, understand, and derive meaning from human language and make it smart in a useful way. So why is it so hard? So let's look at an example. Let's look at this sentence up on top. It seems like a very simple sentence. I saw a man on a hill with a telescope. It's probably simple to you. It's not simple to a computer because it can mean many things. There's a man on a hill and I'm watching him with my telescope. There's a man on a hill who I'm seeing and he has a telescope. There's a man and he's on a hill that also has a telescope on it. Or I'm on a hill and I saw a man using a telescope, right? It's really difficult to be able to pull that out. And that's where natural language processing comes in, at least in this context. It can be used for many different things. So if you look at a more concrete example, something that you might be building or utilizing or a brand would build to be able to interact with their customers. For example, if you're looking to see, I work at Microsoft, so if you're looking to see what the Surface line has and you want a bot that is able to handle that, you can see the first one might be pretty easy to parse, right? Has my order number 1549 been shipped yet? You know, that's not too bad. But what about how fast is the Surface 3? Am I asking how fast it will be to ship to me, or am I talking about the processing power? And the next one, do you sell Acer laptops and drives? Am I asking if they sell Acer laptops and Acer drives, or Acer laptops and also drives, right? Or on the bottom, what kind of display is on the Surface 4? And here's where it gets interesting when you're dealing with bots. We talked about the fact that the text-based games would just give you silly answers or say, I don't understand it. And bots before now would say, I don't understand your question. I don't understand your question. I don't understand your question. I don't understand. And you guys are getting annoyed that I'm saying that, right? People get annoyed at bots when it says that too. If it does it too much, it's gone, it's done. So you got to be able to process things easily and quickly the way they say it. So things, if you look on the bottom one, what kind of display is on a Surface 4? I not only need to understand the intent of what they're asking, I need to pull out the entities in that sentence so that I can use them for a query, so that I can query my database or I can query an API to grab the information that they need. So you can, if you want, and many of you here have, can learn about augmented transition networks or conceptual dependency theory or machine learning for language processing. And then you can go out and use some of the open source libraries. The Natural Language Toolkit is a very popular one, or Mallet if you're a Java programmer. But here's something that I truly believe. I was actually just having to talk about this a minute ago before I came on. And the true fact is that if you think about the app ecosystem, we're in a hub in Santa Monica where we do have a large app ecosystem. The explosion of those apps didn't happen because we had an influx of people who had PhDs or brilliant programmers or just the most amazing minds you've ever met. It's because two things happened. We made hard things easy for them, and we brought them an audience. So if you think of the app ecosystem, they had built-in users, right? And they built platforms that made it easy for developers to create cool things that people use, right? So if you think about bots right now, the audience is there. Now, maybe if you're close to my age, I'll be 50 in a few months, you might not be on these platforms, the Slack, the Messenger, the WhatsApp, the Skype, the WeChat, the Kik, the Snapchat, all of those, right? But a ton of people are, right? Making the hard things easy is there as well. So if you look at things like Google Cloud Natural Language API or Amazon Lex, IBM Conversation, or our sponsor as well, and of course Microsoft Lewis, we make it so you don't have have to be a PhD student. You don't have to have gone to school for natural language processing. You can have an idea and turn that into a billion-dollar app, or in this case, bot, by utilizing and standing on the shoulders of giants that are building these things for you. So remember I said you have to determine intent and define entities. So this is, Lewis, this is Microsoft's version of it, so of course I'm showing ours. It's the Language Understanding Intelligence Service, and it's part of our Cognitive Services suite. So it used to be called Project Oxford, and it has APIs for semantics, it has APIs for vision, it has APIs for voice, it has this API for text-to-speech that's really great because it goes beyond the text-to-speech you're used to, because it allows you to build models around not only the noise, but maybe the silo that you're in. So Lewis is part of the cognitive services. And this is how it works. This is the web interface. And you see over on the left-hand side, these are intents that I want to pull from what people are asking me. I need prices or features, or maybe they're asking for promotions or help. Help is one that people skip. A lot of times if you're talking to a bot and you say help, that works. But if you say anything else like what can I do, or what can you help me with, it doesn't understand it. They didn't bother to be able to handle the simplest of questions. So you can see in this interface what you're doing is giving it utterances like, are you good for anything, or something, I think I put. And you'll see, once I run it, it correctly identified help as the intent I have. Intent has no entities, they just want help, and so I give them help from it. But I can also ask things like, what kind of display is on a Surface 3? And when we run that, it will correctly see that it pulls features, and it'll also pull the entities, the display type, or display, which is the feature type, and the product type, because I need those as a developer to go get the information they need, right? And the beautiful part is, see that little train button on the bottom? You don't have to be a machine learning expert to do this. The machine learning is built in there, and it not only learns from this, but it learns from all the data that we utilize as Microsoft as well. Now, once you've trained it all, you put it out in the wild. And the beautiful part about it is it learns over time, right? So as people are asking questions, it's going to have some that it doesn't understand. You can go in here, and it'll sort them by the ones it thinks it'll learn best from, and you can correct it. So you keep making it smarter and smarter and smarter. The more users you have, the more your bot can be able to handle. Now, what this looks like to the developer is this is still on the website, but this is what they would receive. So if they actually posted a query to that URL down below, and we'll go ahead and do that. Again, what kind of display is on a Surface 3? You get back JSON. So any programming language can parse the JSON. So it's done all the hard work for you on the front end. It's determined the intent. It gives you the percentage of confidence in that intent. It gives you all the other percentages of all the other confidence of intent. And then down in the bottom here, you'll see that it also gives you the entities. And as a developer, I can grab this and pull that data and utilize it in my program, or utilize it in my bot. And so this is an example of a bot. This is an emulator, but this could be Slack or Kik or Skype or anything. You can see I can say what kind of display is on a Surface. It's going to kick back up there. It's going to send me down that JSON. I'm going to query my database, and I'm going to give them the answer they need. But again, more importantly, if I ask silly things like, what are you good for, I'm able to handle that stuff as well. So I don't get the dreaded, I don't understand your question. I don't understand your question. So why NLP is making bots and new apps is, first, technology, it always has to happen. Technology has caught up to the history of bots. Second is the audience is listening, and more importantly, they're willing. Millennials want to work on the things they're comfortable with. They have no problem interacting with a computer, with scheduling things or buying things or doing things if they're talking to a computer, as long as it's able to handle it without saying, I don't know what you're talking about, right? So the audience is there. And then the hard things have been made easy so that developers can go to a hackathon, build a minimal viable product, whether it's an app or a bot, and then turn it into the next billion-dollar company, right? Simple things like Snapchat that was built at a hackathon, right? Simple things like that. My name's Daniel Egan, and thanks for having me. Questions or no? Any questions? Yeah. Yeah, I mean, I think there's, I see three different kind of types of chatbots. There's the enterprise chatbots, which, you know, I was an enterprise developer for a long time. I actually like that stuff, like using a bot to integrate with Jenkins to help you with your build of your, you know, that stuff is cool to me. I like that stuff. So I see enterprise bots or customer service bots, which saves you money by doing that front end stuff to handle the easy questions so you don't have to pay someone to, you know, answer the same 100 questions again. And then I call them kind of the app bots. The app bots, and I'm kind of skipping the brand bots, you know, as well, but I call them the app bots, and that'll be the ones where it's the ideas that aren't, that haven't come up before. There's a local company called Sensei that has a bot that they use to connect to different people and different experts around the country and around the world. You know, it's a very interesting use for bots. The entertainment industry, I think it's wide open. I think people are want to engage. You see every single TV show that has a Twitter feed of people going back and forth. It's the very simplest use of that. But if they can, you know, talk directly to, say, a show, American Idol, whatever it is, and ask information, what season was someone on, and get that information back, I see that as an easy way to tie it into the industry. I mean, that's just one simple example, but I think it's easy to tie it into the entertainment industry. Yeah. You know, I think natural language processing helps things that artificial intelligence needs help with. So natural language processing isn't artificial intelligence. It's something that helps it and something that gives people the ability to take artificial intelligence farther, but not necessarily artificial intelligence. So the bots and, you know, NLP and stuff are kind of a sidestep of AI, but part of the whole ball. Yeah. You know what? There's a million experts here today, just super, super deep, and so I'm not going to define it. I'm not that guy. Done. Okay, one more question. Well, no, I think both sides evolve, and they both need to evolve. If you think of, you know, different words like that millennials use, like, you know, dabbing and twerking, and, you know, traditional computers have no idea. It's, you know, gibberish to them. So I think both sides evolve. Our language evolves, and the other side needs to adapt. Is that what you're asking? Yeah. All right. Thank you.
Thank you, Daniel.